Good morning. This session will be discussing about agarose-gel electrophoresis. Agarose-gel electrophoresis is grouped under zonal electrophoresis. In our last session, we have discussed about the other two types of zonal electrophoresis. One is paper electrophoresis, the other is cellulose acetate electrophoresis, which are now not being widely preferred. The third type, which is called as gel electrophoresis, is being widely used. Under gel electrophoresis, there are two major types. One is agarose, the other is polyacrylamide. These two are the most popular gel electrophoresis, where using this you can separate both nucleic acids and proteins. Now coming to agarose gel electrophoresis, we use agarose as a supporting medium to perform the electrophoresis process. Agarose is a linear polymer extracted from seaweed. This was first used in biology when Robert Koch used it as a culture medium for tuberculosis in the year 1882. So these used to be consumed by the humans in the 17th century. Well, coming to the process of electrophoresis, the process of electrophoresis is carried out in an electrophoretic chamber. This is how a electrophoretic chamber looks, where the molecules, especially like DNA or RNA, are loaded at cathode end, and they are made to move from cathode end to the anode end. Since it is a electrophoresis process, a electric supply is needed, so it will be supplied under by using a power pack. Now how fast will the DNA migrate in the electrophoresis depends on the strength of electric field, of course. The second one is the choice of the buffer what we use, and also the density or the percentage of the agarose gel that I prefer. Now coming to electric field, which means most commonly the DNA molecules are separated in a range of 50 volts to 120 volts. Size of the DNA we'll talk later. Buffer, the most commonly used buffer are T, tris, acetate, EDTA buffers. This plays a major role in the process of electrophoresis. Why tris, acetate, EDTA has become popular? Because tris charges the ions of the buffer and speed ups the process of electrophoresis along with acetate. Coming to EDTA, this inhibits DNases. DNases are those which degrade DNA. So our aim is to separate DNA. So if any DNase is present in our work environment, though we isolate our DNA, it can degrade our DNA. Hence, we need some kind of inhibitor which can inhibit DNases. So EDTA is the economical which are commonly mixed up in the choice of our buffer and used during the process of electrophoresis. And the third important point in the choice of the electrophoresis process is the percentage of agarose gel. Most commonly 0.8 to 1.2% of agarose gels are preferred depending on the size of the DNA what you are going to separate.